Question 7. A casserole is placed in a 350-degree Fahrenheit oven at 5 p.m. So I'm just going to draw a little sketch here. Here's the oven at 350 degrees Fahrenheit. And here's the casserole in the oven, and I'll say that's at temperature capital T, temperature T. Now we are given here a positive temperature difference model, a PTD model for this situation. So Newton's law of heating has already been applied here, at least that first step where we model the positive temperature differences. In this problem, in this heating problem, the T temperature is less than 350 degrees, so that temperature is increasing toward 350 degrees, and the positive temperature difference is always equal to the higher 350 degree temperature minus the temperature T of the casserole. Just to make things a little bit easier for me here, I'm going to change the name of the independent variable in this problem from small t to x so that it's easier to talk about. So we have that positive temperature difference model as a function of x measured in minutes after 5 p.m. Now, so we got that positive temperature difference model. It's right here. And we actually want to make predictions about this casserole's future temperature. So we actually want to model T. So let's add T to both sides of this equation, and let's subtract PTD from both sides to rewrite it as T equals 350 minus PTD. And that means at any time x, using my new name for the independent variable, at any time x in minutes, T of x is going to equal 350 minus the positive temperature difference at x, which is 285 times 0.988 raised to the x. So now we have that temperature model, and we can proceed with part A. What will be the temperature of the casserole at 6 p.m.? Well, 6 p.m. is 1 hour after 5 p.m., and 1 hour is 60 minutes, so we want to calculate T of 60. Let's do that. Turning to our calculator, the model is, I'm putting that into Y1, the model is 350 minus 285 times 0.988 raised to the x power. So there's the model, and if we plug 60 into that, T of 60 on the calculator would be Y1 of 60. And that's, let's see, we want to round to 1 decimal place. That's 211.9 degrees Fahrenheit. That would be our prediction. Part B. If you want to take the casserole out of the oven when its temperature reaches 250 degrees, so when the temperature T is equal to 250 degrees, when should you do that? When will that be? I'll say, when will that be on the clock? First, we'll figure out what's the value of x such that T of x is equal to 250. We can solve that by putting that target into Y2 and then finding a viewing window where we can see the intersection point between those two curves, Y1 and Y2. I'm just going to try, at 60 minutes, we're already at roughly 212, so I'm just going to try 120 minutes. Let's see if that works. So I'm going to graph this on the interval from 0 to 120 minutes and run zoom fit to let the calculator adjust the output axis. we're looking to figure this out to the nearest minute. So there's the intersection point. Calc intersect. Enter for first curve, enter for second curve, enter for guess. And that intersection point is at, to the nearest minute, it's 87 minutes. So x is equal to 87 minutes. Now that's 87 minutes after 5 p.m. 60 of those minutes would take us to 6 p.m. and then there's 27 more minutes. So 6:27 would be the time on the clock.